Okay, see, today we are going to learn one more for differential equation. Okay, we have already learned this separable variable. We have already learned homogeneous, and the other one is substitution. Homogeneous, I have already shown you how to identify whether it's homogeneous or not. For homogeneous case, you always substitute y equal to vx. And then for substitution one, of course they will give you what to substitute. The question will give you if other than homogeneous and you need to substitute. If they don't give you, then cannot do. They will give you what to substitute, y equal to 1 over x or whatever. And then here, today we are going to learn linear differential equation. Okay, so if you want to learn this is the last one for this topic. So if you want to learn this, okay, let us look at this first. Okay, when I differentiate this y exponential 3x, then you get e 3x, differentiate y dy dx, plus and then y, and then differentiate the e 3x, you get e 3x, then differentiate the 3x, you get 3. Then this 3 come from differentiate the 3x. Yes or no? This one you have learned already, so you should know, no problem. Okay, now I rewrite this. I put this one right. I write here e 3x dy dx plus 3e3x y equal to d dx y e 3x. Okay, why I write this one in red? Because you see, why I want to write this one in red? Just because you see, every term they have this red color, isn't it? So, not very clear. Okay, this red color means, you see, every term have this red color means this is called a factor. If everyone has this, we call it a factor. Okay, we call it a factor. So this is called the integrating factor. You see, all of them they have. So another thing you can see here is this one. Here you have two terms. We can combine them into one terms like that with the integrating factor. Okay, now you go to the next one. So the integrating factor is e3x. Okay, e3x. Actually, how to get the integrating factor? To get the integrating factor is exponential, then integrate the 3x. That's why you get e3x, the integrating factor. So you see, every term must have. Okay, now you look at this one, the second one. When I differentiate this one, I have e negative 5x dy dx, then y, then differentiate this one, you see I get a negative 5. Where the negative 5 come from? Come from differentiate of this. So I rewrite this one, e negative 5x, red, to show you this is the factor. And this is called the integrating factor. How do you get this integrating factor? Is integrate the negative 5. You see or not? Integrate this. So you see, I have this here, I have two terms here. I can combine into one term. I can combine them. Okay? So I can combine them. Okay, now look at this one. When I differentiate this, okay, this one you know how to differentiate. Again, you see, then I rewrite this. You see, I have e sine 3x, e sine 3x, e sine 3x. You see, I rewrite. So again, this is the factor. So another thing, I can combine these two into this. Integrating factor, how to get? I integrate the cos x. Now you look at this one. When I differentiate this, I get e tangent x. Okay, I rewrite this one. I have this. Okay, I write this in red to show you. You see, every term, all the terms, they have this. So we call it the integrating factor. Okay. So what am I trying to tell you here? Another thing you must see. This is y. This is dy dx. So this one, if you have y here, if you have dy dx here, then we call this as what? Okay, here I write. Actually, this one I do the same one. Just now I did already, but not very good, not very clear, so I redo again. So you have y and dy dx like this, y dy dx. This one we call first order. First order is because dy dx, linear differential equation. So you have y dy dx, we call it linear, okay, differential equation. So you have y dy dx, d2y dx square. Because of d2y dx square, we call it second order. And then you see you have y dy dx, d2y dx square is called linear differential equation. And then here, if I have y dy dx, d2y dx square, d3y dx cube, we call it, because of d3y dx cube, we call it the third order. And then y dy dx, all this, we call it the linear differential equation. Okay? The first derivative, second derivative, second order. We have first derivative, first order. We have third derivative, we call it third order. Okay? And all these are linear differential equation. And then for linear, this should be 1. So you see, if you look at this y and dy dx, they are linear. They are linear. And then with the integrating factor, the linear differential equation, we can combine them into this. We can combine into one like this. After I show you later, I will show you again. Linear must be 1, but with the integrating factor, we can combine. Same thing, linear with the integrating factor, we combine. Linear with the integrating factor, we can combine. So therefore, now you look at this one. Okay, let's say I give you this. Okay, look at this one. dy dx for y. If you look at the y and you look at the dy dx, this is called linear. But you cannot combine these two like this. It's wrong. Okay? You cannot combine these two to write it like this. This is wrong. Why? Because there is no integrating factor. So you shouldn't write like this. This one cannot be equal this. You cannot combine. So what we do, you have to find the integrating factor. Just like here. You must have the integrating factor, then only you can combine them into one like that. Okay? Into one like this. You must have the integrating factor, then only the linear one you can combine. You must have the integrating factor, then only the linear one you can combine. The linear case, then only you can combine with the presence of the integrating factor. So now we have to find the integrating factor. That's why the integrating factor is so important in this case. So to find the integrating factor, you integrate the 4dx. So you get e for x. So you write down the integrating factor here. You put down the integrating factor here. Then you can combine. This is correct. That means these two you can combine into one. Okay? Same thing like here. This is linear. Why I say linear? You look at the y dy dx, and then this is 1. Okay? So now, but you cannot write like this. It's wrong. Okay, don't write like this. You cannot combine yet because something is missing. What is missing? Integrating factor. So to find the integrating factor, you exponential, you integrate this. So you get integrate this, you get ln x. E ln x is x. So the integrating factor is x. So you multiply x, multiply x. Then with the x, integrating factor x, then you can combine. You see, two houses now combine to get only one house. You combine them into one house. Okay, now another one. Here, also linear. Linear because I look at the y and dy dx. So this is linear, but I cannot write like this. You cannot combine like this. This is wrong because you don't have the integrating factor. That's why integrating factor is very important in this part. So how to find the integrating factor? Integrate this. Okay? So integrate this, you get x squared over 2. So with the integrating factor now, you can combine them like that. Two houses to become one house. Of course, this is easier. So later, got two houses, we are going to combine them into one house. This is what we are going to learn in this part. Okay, we look at some more. Still got some more. Okay, you look at this one. Okay, you look at this one, and if you look at this one. So this is linear. So So if this is linear, so of course I cannot combine it like this. Okay, I cannot combine, I cannot write it like this. This is wrong. You shouldn't write it like this. Huh? If you write it like this is wrong. Okay, this is wrong. So what we do is, you need the integrating factor. So if you have integrating factor, you can write like this with the integrating factor. So you see the integrating factor, how to get exponential, integrate this. So integrate this, you get x cubed. So with the integrating factor, then you can combine. Then this is correct. So again, this one, actually we have two houses because of linear. We have two houses. We combine them into one. Okay. Next one. Okay, look at this one. If I look at this y, then this is again linear. Okay, this is linear. Then what we do, but even though this is linear, I cannot combine them like that. You don't write like this. This is wrong. This is wrong. You don't write. You cannot combine them like that. So what we have to do here, we find the integrating factor. Why we find the integrating factor? We have to combine them into become like this. So to find the integrating factor, we integrate it. Integrate negative sine x, we bring out the sign, the negative sign, then integrate sine x, you get negative cos. So you get e cos x. So with the e cos x, the integrating factor, then this is correct. Okay, so you see again, these two, we can combine them into one, like that. Okay, then here one more. Okay, you look at this one, this dy dx, and this y, this is linear. So because this is linear, then what we do here, we find the integrating factor. Why? Because without the integrating factor, I can't combine it like that. Cannot. So I have to find the integrating factor, then I can combine. So the integrating factor is negative 1 over x squared. I bring down the negative, then x negative 2, integrate negative 1 over negative 1. So it's e1 over x. So I put down the integrating factor, integrate. Then you can combine. You see, that is why the integrating is so important. Integrating factor is so important, so that we can combine. Without the integrating factor, we cannot combine. Even though it is linear, even though this is linear, you cannot combine without the integrating factor. Okay, it's because of this. Just now, beginning, I have already shown you when we differentiate, you see you have all the integrating factor coming out, isn't it? All the integrating factor coming out. Okay, so you can look at this one first, you go through slowly, then you understand why integrating factor is so important. Then only I can teach you how to integrate, how to solve the differential equation, the linear type. Okay.